Welcome to all of our dreamers, makers, and change makers of tomorrow. You've made it to our launch pad as we prepare for a 1-hour journey into the future. My name is Donnie English, and I'm the program manager here at Smithsonian Arts and Industries Building. I'm also your lead future agent who will be guiding you through our trip. This program experience is one of many special events that will be happening here at the Arts and Industries Building as we celebrate the reopening of our historical building through a groundbreaking exposition entitled Futures. This imaginative journey in virtual talk series is called Meet Us in the Futures. Here, we will highlight the ideas of a few guest future agents who are striving to achieve a better tomorrow. Today, we will be taking on a journey into a future world of water. We will explore how the power of science can be used to help humans on our planet gain equal access to clean, drinkable water and help our oceans receive the necessary care and protection they deserve. Today's live stream of Meet Us in the Futures is sponsored by Comcast and NBC Universal. On our journey into the future of water, we'll be joined by a few of our experts who are helping us to achieve this world. First up, we have Dr. Omar Yaghi, University of California, Berkeley chemistry professor. Dr. Omar Yaghi is listed by Thomson Reuters as one of our top 5 most impactful chemists worldwide. He was born into a refugee family and raised in a humble home in Jordan with no electricity or running water. Growing up under these conditions made Omar keenly aware of the hardship of water scarcity. At the age of 15, he moved into the United States on his own to study, eventually joining UC Berkeley in 2012. He pioneered a new field of chemistry that is named reticular chemistry, apologies. The rapid growth of reticular chemistry has given rise to one of the biggest expansions of materials in human history and has led to a plethora of new applications. Next, we have Dr. Eugene Kopstein. Dr. Eugene Kopstein is the Chief Technology Officer for Water Harvesting, Inc. He began his career in chemistry at Novosibirsk State University in Russia, completing his PhD. In 2014, Dr. Kopstein moved to the United States to pursue his second PhD in Professor Yaghi's research program at UC Berkeley. There he studied structures of novel aluminum-based metal organic frameworks, known as MOFs, in their water absorption capabilities. Upon his graduation in 2018, Dr. Kopstein joined Water Harvesting, Inc., where his goal is to advance MOFs from his doctoral studies to market-ready solutions for urgent water scarcity issues. We're also joined by Dr. Asha Devas. Dr. Asha Devas is an internationally acclaimed Sri Lankan marine biologist, ocean educator, pioneer of long-term blue whale research within Northern Indian Ocean and strong advocate for and long-term blue whale research within the Northern Indian Ocean and strong advocate for diversity and equity in marine conservation. She has degrees from the University of St. Andrews, University of Oxford, and the University of Western Australia, but escaped academia to establish her own Sri Lankan-grown nonprofit Oceans Well, which is Sri Lanka's first marine conservation research and education organization. Her work has been showcased internationally by BBC, the New York Times, TED, and National Geographic, just to name a few. Finally, but not least, our moderator will be Ashley Molise. Ashley Molise is an independent curator, producer, and festival organizer within 15 years of work across the nonprofit sector. She is the curator of 4 Futures, Arts in Industry Building. She also specializes in public art, new media, and large-scale design and build projects. Ashley received her MFA in curatorial practice from Maryland Institute College of Art in 2014 and her MA in arts management from RMIT University in Melbourne, Australia in 2010. All right, Ashley, we're now ready for blast off.
Ani, thank you so much. Thank you everybody for joining us this evening to talk about the future of water. I'd like to thank our panelists as well as you all for joining us tonight. Before we get started, the Smithsonian Arts and Industries Building gratefully acknowledges the Native peoples on whose ancestral homeland we gather, as well as the diverse and vibrant Native communities who make their home here today. We acknowledge that AIB sits on the traditional territory of many nations, past and present, including the Natchitoches, Anacostia, and Piscataway nations, and pay our respects to the elders past, present, and future. To get us started, we wanted to acknowledge some of these core crucial issues around the future of water. The future is certainly uncertain, but here we have amassed some of the greatest minds to think about this really pressing and urgent issue around water scarcity and water access. We all know that roughly 70% of the Earth's surface is covered in water. About 2% of that is usable fresh water, and only about 1% of that is actually drinkable. And UNICEF has recently published some pretty startling facts about the rapidly increasing scarcity that's going to affect much more of the world's population. So roughly 2/3 of the world's population, so about 4 billion people, currently experience severe water scarcity at least 1 month out of the year. And as we think about the future, in years not too distant from us, in such the year 2025, half of the world's population could be living in areas facing water scarcity. And by 2030, some 700 million people could be displaced by intense water scarcity. So some really frightening and urgent factors that we need to be addressing. And like many things, we know that there isn't just one silver bullet that's going to enable us to find solutions to these crucial issues. And so with that, I'd like to open up to our panelists to begin our conversation about what we can think about and do and action for the future of water. To get us started, maybe Dr. Asha, I'll start with you. If you don't mind telling us briefly where you're calling in from and maybe a little bit about your relationship to water.
Great. Good morning. I'm calling in from Sri Lanka, where it's 5 o'clock in the morning right now. So it's a pretty early start. My relationship to water, I think, is an obvious one. I'm a marine biologist. My life revolves around, either I'm in, on, or around the water at all times. And the ocean is vast. It surrounds us. I come from a tropical island. So yeah, water is a very integral part of my life. And it's what I think about. It's where I get my peace. It's where I get my exercise. So yeah, I don't know. It's just very much a part of me.
As somebody who also grew up with a very close relationship in her childhood to water, that completely resonates with me. Dr. Omar, what about you?
Yeah, thank you. I'm calling from University of California, Berkeley, here in the Bay Area. And my relationship with water is that I was born and raised in a desert region in Amman, Jordan. And unlike Asha, we didn't have much water. Water is everything there. It's hygiene, it's health, it's food, it's everything. Your whole life revolves around access to water. So yeah, I'm happy to be here and participate in this program.
Dr. Eugene, what about you?
I'm joining from a hideout here in the Bay Area, specifically at Berkeley, and I'm not alone here. Actually, behind me is Madame Curie, definitely an inspiring and iconic character for all scientists around the world. And my relationship to water is pretty simple. I'm trying to address one of the potential crises, which is related to water scarcity and water purity. And I'm working on a technology which will, at some point, definitely address one of those challenges.
So that's a great intro to my next question. Actually, why don't I start with you, Dr. Eugene? Do you want to talk about a little bit, for those who aren't familiar, to share a little bit more details about your current work to ensure the future of freshwater access and healthy oceans?
Sure, but basically, currently I'm a Chief Technology Officer at Water Harvesting Inc., a startup which originated from the research done at Professor Yagi's lab. And the core of this technology is to implement a novel material, which I'm sure that Professor Yagi will describe in great detail, meta-organic framework, into a simple device which can harvest water anywhere at any moment, and it can be distributed, and this water can be personalized. Maybe Professor Yagi can talk more about it.
Yeah, actually, Dr. Omar, I recall Donnie dropping in reticular chemistry into our introduction. Do you mind breaking that down for our audience a little bit of what that means?
Sure. The word reticular means net-like. And from this name, we have invented a whole class of materials that would look like networks. And basically, they're made from nature's building blocks, minerals, and organics. And we figured out a way of stitching them together to make structures that appear to the eye like these crystalline powders. And the amazing thing about these materials is that in 1 gram of material, you have the footage of an entire football field. And that means that in every grain, on the molecular level, you have so much space into which to store water. So the amazing, I think, development in this field over the last, since we invented it back in the mid-1990s, is that we are able to go into these atomic level pores and modify them so that they can seek out water from different sources, especially from air, and concentrate it into the pores, so that now you have a way to then take out this water and condense it and make drinking water. These are the materials that constitute the heart of the device that Eugene is developing in the startup company.
It's a really incredible innovation, and we are so pleased to be showcasing this prototype here at Futures. It is just behind me. I believe we have a closer shot of it. And we're just so fascinated about the process. And one of the most interesting talking points that I have conversations with visitors about is how this doesn't really need relative humidity to function. And I think that that's what separates and makes it distinctive from other water harvesters that have been tried or even tested. Is that right? Is that a correct understanding?
Yeah, actually, I think you touched on a very important point, which is that these materials we call metal organic frameworks, or for short MOFs, because they can be designed on the atomic and molecular level with high precision, we're able to program them to take out water from very low humidity. So in the desert, where 1/3 of the world experiences water stress most of the year, the humidity levels are below 40% relative humidity. It can go down to 7% relative humidity. And nothing works in these low humidity regions except these MOFs that we have invented, and specifically the MOF that constitutes the inner part of that device behind you. So the MOF is able to take out water from very low humidity, which means it can also take it out from higher humidities. And that's really what we're trying to do in achieving our vision of harvesting water from air anywhere in the world at any time of the year. So that's really what we are working on here.
That's so interesting. Dr. Asha, as somebody whose whole life and work revolves around saltwater and not necessarily fresh water, I wonder what this kind of water access would mean to your work.
I mean, I think, when you think about the ocean, it is 70% of our planet, but it represents 99% of habitable space and 97% of all water on the planet, right? But it doesn't mean that it's usable in its current form for the purposes as Dr. Omar talks about, right? Like fresh water is life. Seawater is life in a very, very different way. It's the ocean is what regulates our climate. That's where 17% of the world's population gets their primary source of protein. There are livelihoods, billions of livelihoods that depend on the ocean, whether it's as fishers or as divers. We get our medicines from the ocean. The list is endless. So the ocean is a very incredibly important space for us. But for the purposes of human survival, we do have to recognize that the oceans or the salty marine water in its current form doesn't work. So as we start to use up more of our water sources, as we, this is this year is our 6th year in a row that we've had the hottest year, right? Like every year we outdo ourselves, which is kind of remarkable. But if you think about it, every year if we get hotter, we're actually going to experience more extreme weathers, but more drought across the world. And what is a very fundamental something that's very fundamental to human existence. So for us, as we think about that, as we go into drought, which the ocean has a role to play in climate regulation and in the water cycle, and as we we have less and less fresh water in the world, we might have to actually turn to other sources, just like the water harvester. So right now, people use desalination, but there's pros and cons to desalination. And so, looking for these alternatives, as Dr. Omar talks about, is obviously going to be integral to our long-term survival.
So one thing I'm so interested in hearing from actually all three of you is, what do you think, the future of water could really look like? I had thrown out some really, somewhat alarming and anxiety producing statistics from UNICEF. But obviously we need not just solutions, but, a hopeful approach to seeking those solutions. So Dr. Asha, maybe to start with you, what do you think the future of water looks like?
So I'm going to talk about this in the context of our oceans, because that's obviously my area of expertise. And, the thing is, right now, unfortunately, every time you open a newspaper or you go on social media or you watch a news program, we talk about the oceans with a lot of doom and gloom, right? And that's not necessarily helping our situation. It is true our trajectory isn't very good. As I said, this is the hottest year. Like last year was the hottest year on record. That's like 6 years in a row we've outdone ourselves. That is a problem, right? So the hotter our oceans get, the less phytoplankton there is. So that's like the tiny microscopic plants that float at the surface of the ocean that are really the base of every single food web. And they, if we have less of them, we have less of absolutely everything else, because if there's no plants, then you're not going to have the things that eat the plants and the things that eat the things that eat the plants, and so on and so forth, right? So you're going to have less fish in the ocean, which is obviously going to impact food security, which is a concern. Like I said, a lot of people depend on fish for their source of protein, but then there are the livelihoods associated with it. So there are obviously going to be issues like that. Also, the capacity of the ocean to regulate our climate is going to break down, right? So if you think about things like the fact that the ocean is the largest carbon sink. So by carbon sink, I mean it actually traps extra carbon from the atmosphere at the depths of the ocean. And by holding it down there, it's buffering us from the worst impacts of climate change, right? Because there's a reduction in that. There's that all that extra carbon that we're producing very freely with all our activities, with very little thought, it would be floating around and heating our environment much more, if not for the fact that the ocean is sucking some of it and keeping it trapped at the bottom as a carbon sink. So I would say that, I could go on about this, but the future of water as we stand is bleak. But I want to think that today's conversation is really like our first step towards trying to really think about how do we address our challenges, right? Because we do have to think about the fact that it's a very, very large part of our planet. And if we aren't sort of taking the measures to look after the oceans, we're going to see the impacts on land, which will obviously have very huge negative repercussions.
So true. And it actually makes me think about, some of these ideas, some things like Triton City, which was, designed by Buckminster Fuller, or even some of the work by the Oceanics group and what they're trying to do to make a floating city, and how the future of our water surfaces might be real living scenarios for people. And that might be the near future for us. It's so fascinating to think about that relationship between freshwater needs and saltwater realities, and how the two mirror each other and link together to form a holistic climate system that we still need to be quite cognizant and aware of in our decision making, in our policy directives, and even in our educational outreach, I would say. Dr. Omar, what about you?
Well, when you think about it, we have a lot of water in the atmosphere. we have over 13 trillion cubic meters of water in the atmosphere at any one time. That's almost as much water as we have in rivers and lakes on our planet. So finding a way to harness this water is going to change the way we think about water. I would say it's going to transform our view of having access to water. Imagine these materials that I just described being placed in a device like the one behind you that may work on electricity or on solar panel, or they may also, as we have demonstrated in prototypes that we ran in the desert, that they required no energy input aside from ambient sunlight. Just by exposing them to ambient sunlight, they will take up the water from desert air and deliver pure, clean water. So think about the wired phone. I know some of you may not even remember what those look like, versus the wireless phone. So once you are off the grid with these devices, now you're giving people in the world, the individual, water independence. And so you have control over your drinking water, the water you use for household use, and you can move it wherever you like. You can live wherever you like. So I think that this is a very powerful technology that Eugene is developing in water harvesting. And of course, there are many other initiatives around the world now on taking our materials and our inventions. And we are, of course, involved in some of these, both in the US and abroad, to make these everyday items delivering water from the atmosphere, clean water. I should say that the MOFs that I have shown, these powders, they are where the water resides inside the structure. Later, if I have a chance, I will show a movie. They are natural filters for water, so only water can get in. No other contaminants from air or from the environment would enter those pores and contaminate the water. I would like to say that perhaps Eugene can be given a chance to elaborate on his testing of the device in California in the middle of the wildfires that we experienced in the last couple of years.
Sure. And I'd like to reiterate that, yes, aside of water scarcity issue, definitely there is a challenge of sustainable water purity and quality. So it's crucial to recognize that tap water that we consume every day, it may have PFAS or forever chemicals in it, heavy metal elements, maybe some volatile organic compounds. And think about it, that you may really follow your strict diet and you consume only fresh produce, but if your local tap water is not up to BPA standards, you may be exposed to this long-lasting damaging effects of impurities in water. And definitely, this is far more pronounced in water-stressed regions around the planet. Now, as for the device specifically, which Professor Yagi mentioned, yeah, not only we can capture and deliver water, we can deliver it as pure as it gets. It's essentially distilled. And while we were running our water harvesting experiments during the wildfire season here in Bay Area about a year ago, the samples, the water harvested samples that we sent out to an independent lab in order to conduct chemical analysis testing, well, they revealed that there was no pollutants coming from the air. In essence, the water vapor, which is captured by this material, by meta-organic framework, well, it's pure. There's nothing present except for water molecules. And that's because what Professor Yagi mentioned, these meta-organic frameworks are natural filters and they only capture water molecules.
It's incredible. I think it's not just incredible about what the MOF is able to achieve, but we, and something Dr. Omar has already acknowledged is that the second part of the water issue isn't just the scarcity of being able to access it. It's also what happens when you have a water source that is contaminated, how much effort and labor needs to go in, how many resources need to go in to purifying that water source. So the capacity of the water harvester is pretty significant in that it's not just working to capture really pure water and consolidate it and condense it in a way that makes it usable, but speaking to something that you raised earlier, really does seek to provide growing water independence. And I think water independence is a really important thing to unpack here. So what do you think that looks like? Does it look like something that's just in the home, or can we scale this up so that water independence is something that whole communities can begin to achieve?
Well, in this specific example, the device you see behind you, this unit can make up to 1 gallon of pure drinking water daily, and it only requires about a half a cup of the novel sorbent meta-organic framework material. So other parts of the unit are very cheap, and you can think that potentially, if this scaled up properly, it can be placed on every single kitchen top around the world, as long as there is source of electricity. And as Professor Yagi mentioned before, we've already proven that we can make those units which can only rely on ambient sunlight. So yeah, as long as you have this framework, as long as you have this material, you can build this unit and place it anywhere around the world, and now you're water independent.
Dr. Asha, I'm interested, maybe if you don't mind me putting you on the spot a little bit to speculate, but if you had access to a water harvester for your own research while you're out in the ocean, how would that maybe change what you're able to do, or even maybe where you could begin to explore?
That's an interesting question, but I mean, it's a, I think just having access to fresh water wherever you are is always a plus. So I think, unfortunately, though, for ocean expeditions, there are other limitations that are larger than like the access to fresh water, because we're still at the stage where we can carry, our fresh water perhaps in different ways. If you were, of course, out in a very remote place, far off, and you wanted to, I mean, I don't know how big these devices are, but say it was something that's a pretty small portable device, then maybe instead of having to pack your boat with freshwater supplies, you had more room for, say, food or equipment, and you could have this harvester that might just take up less space, but still give you a steady source of fresh water. So yeah.
That's what I wonder about places like in the South Pacific, where you're so far away from land masses where you can revitalize your own water supply, and you're really at the mercy of what you could carry with you. I think that really speaks to the kind of forecasting where we're looking at people being displaced and having to sort of carry with them only what they're able to. So I'm interested to hear a little bit more about how the water harvester might be able to, expand that water access, maybe 10, 20 years from now, after it's been sort of tried and tested in the public. How do you see this rolling out to become a sort of day-to-day, maybe even appliance that people might have in their own homes?
Well, I think that the first generation devices, as Eugene already mentioned, could be a small appliance that is at the that's in the kitchen, like a microwave oven. And in fact, these wouldn't have to be much larger than a microwave oven to supply enough drinking water for our entire household. The next generation would be larger devices that would potentially sit outside the home and can deliver enough water for the entire household need, not just drinking, but also for cleaning and hygienic purposes and cooking and so on and so forth. All of these would be independent of the power grid. Both technologies are available. And I want to also mention, very importantly, is that since these work at very low humidity in the desert region, they also work in other regions of the world where you have plenty of water, but the water is not drinkable. Even in the most industrialized countries in the world, we still have questions about the cleanliness of our water. So this is why we think that the vision of having these anywhere in the world working at any time of the year is real. The potential is real. It's beginning to be realized, especially by this prototype that you see behind you. Needless to say that we have done many laboratory to desert tests. So for example, these materials have been tested in the Mojave Desert, which is one of the driest deserts in the world, from the Arizona desert. And the MOF can stay in the device for many, many years without having to be replenished or replaced. And at the end of the journey of the device, the MOF can be, the constituents of the MOF can be separated into the starting building units and then reassembled, a process that we can carry out in water with absolutely zero discharge. So it's completely sustainable process. Like I said, the MOF, the amount of MOF, let's say in that water harvester behind you is no more than half a cup. That's about 100 grams of MOF, okay? That's gonna be delivering 4 to 5 liters or a gallon or more than a gallon of water every single day for many, many years. As Eugene has been testing at Water Harvesting Inc., that this MOF has been tested for tens of thousands of cycles and in many different weather conditions, and the performance is still untarnished.
I think you raised a couple of really good points. One thing that's so important about thinking about the future is testing, is R&D, is these things that go into trying to find these solutions. So Dr. Eugene, maybe I could ask you, what are some maybe surprising facts that surfaced in your own research, either through Water Harvester or even some things that you uncovered in your PhD programs?
Well, I think first of all was what I was always worried about water purity of the samples which we were to collect. And it appears that this MOF, this material is so remarkable that it does not require any additional filtration, any additional devices which you can find at home where you try to purify tap water and turn it into something which you can drink without worrying about any contamination. And that's because of the natural filtration which this material provides itself. And I was really surprised that it doesn't require any additional work aside of figuring out how to turn this powder, which Professor Yaga showed, into something, into some form factor, which can be placed into a miniature device and then placed on the kitchen top and deliver this water, which can be of drinking quality.
Ashley, I do want to just add, just remark on your in regard to your question. You know, I'm a scientist, I am a researcher. I'm sitting here next to my labs where there are a lot of students who are trying to uncover the secrets of nature and trying to perhaps convince nature to do things that we normally don't see. So they're trying to make discoveries. And the way we discovered the water harvesting was not intentional. That was, we were looking at carbon capture. And when you capture carbon from air, you also have to reckon with the presence of water in air. So we were studying how does this these materials behave in the presence of carbon and water. Then we observed that one of the MOFs took up water at relative humidity of 20%. And more importantly, is that we can take the water out at very low temperature or at temperatures that you would access in the desert, like 40 degrees Celsius. So that immediately told us that a material like this that can be placed in the desert at night to take up the water, and during the day when it heats up, the water comes out, and you don't need any energy input aside from the sunlight to heat up the MOF so that you can harvest the water. I give this example because we as scientists, oftentimes are motivated by solving intellectual questions. Okay, we go into the unknown and we try to understand nature. And for us chemists, we try to understand how molecules interact, how to target certain structures that may not be there. But in the process, we learn. We learn from some failures and some successes, but at the end, it's all a learning experience, step by step, towards achieving a discovery. And you don't, when I started this research, I was not looking to solve the water problem. I was looking to solve a chemistry problem, which is how do I stitch molecules together to make materials like this? And this then ended up having many, many applications, including the water harvesting, but also carbon capture and hydrogen storage and natural gas storage and many, many other applications. So I just wanted to mention the power of basic research for the sake of advancing knowledge without necessarily having to target a specific societal need. I think that that's a component of research that is often uncelebrated and perhaps not sufficiently supported.
What kismet. I had no idea that that was sort of the founding of the water harvester. And what a fantastic story. I think we know so many things about, needing trial and error and needing to prototype. It's things that we demonstrate here in Futures, whether it's through the water harvester or through other objects. So I'm so thrilled that you surfaced that in this conversation. I think that there's this misunderstanding potentially that, you have the one track of research and you just pursue it doggedly and it surfaces the exact outcomes that your hypotheses were trying to prove. And I think we all know that it doesn't really quite work that way in the real world. Dr. Asha, maybe you could speak to your research a little bit.
Just in the general context, or in what context would you like me to talk a bit about?
Well, I think we heard a little bit about these things that surface maybe with some surprise or maybe some unintended learnings that come from it. Have you ever had an experience like that in your work?
Yeah, I mean, I would say that my career was it started in kind of a similar way. One thing is, I wanted to be an adventurous scientist as a kid, but grew into this idea of a marine biologist. I come from a country where there weren't any marine biologists before me, so it caused a lot of confusion, I think, for a lot of people. But one thing was I told people I had to leave the country to go study to do marine biology because I couldn't access it here. And people were like, okay, well, what are you going to do with that? Or they just thought it was a passing hobby. And I just kept saying I was going to come back and serve my country. But I didn't know how, right? Because there wasn't really like this already existing niche. And I think that in some ways, that's what saved me, is that I didn't have this clear-cut idea on what exactly I was going to do as a marine biologist in Sri Lanka, even though we have 8 times more ocean area than land area. So we do have a vast ocean space. You'd think marine biology was the one job people would do. But so for me, I was very open-minded about the journey. I just knew I wanted to work in this space. I went to university where we had a very big focus on marine mammals. I had an interest in them. But again, I didn't know how that was going to apply back in this long-term goal of mine. And, basically a few years later, I find myself on a whale research vessel that was, in Sri Lanka. It came out of San Diego, but it came to Sri Lanka. And I had this very big eureka moment with an aggregation of blue whales and a floating pile of whale poop, which is literally the key to my story. And that's my eureka moment. And so, that's when I realized wow, okay, wait, there's this, it turns out it was a unique population of blue whales. And I discovered that they don't migrate, which is very unusual because normally blue whales will go to cold waters to feed and come back to warm waters to breed and calve. But again, I had no expectation of that. So when I saw it, I was able to sort of interpret what was happening based on what was known, but then also with the realization that science is constantly evolving as well, right? So we always put science out there as if it's a fact, but it's really not. It's a fact in that moment based on the best possible information we have. but it can change. And that's sort of like what I was able to show, is that we've got this population, and unlike any other blue whale population in the world, it's not migrating. And because I had an open mind, I was able to see that, right? Whereas my colleagues were more like, yeah, but this is not possible. Oh no, there must be something else happening, right? Because they were fighting back. So I do think there's a lot of value in having a sense of where you want to go, but also not being so close-minded that you miss out on the opportunities of all the other things that could happen. So you need to kind of maintain peripheral vision in some ways while you're kind of on a track. And I think that's kind of demonstrated even in Dr. Omar's story.
Yeah, I think so. And I love what you say about eureka moments. Here at Futures, we're all about the possibility of the future. And we love eureka moments because it does surface some of the more surprising elements of what can become these fascinating journeys, whether it's yours with whale poop, which I absolutely love, or it's Dr. Omar's and trying to do carbon capture and then surfacing this fantastic prototype that has the capacity to really change water access. With that, actually, Dr. Omar, I recall that you wanted to share a little bit of a video. So why don't we take a moment to sort of cue that up? I just wanted to take a quick pause to remind our audience that we will have time for a Q&A coming up in a few minutes. So we will be hearing from you and asking and surfacing your questions. We're really excited to hear what you have to ask of our panelists. But with that, Dr. Omar, why don't you tell us what we're looking at?
Yeah, we're looking at a crystal of the moth that is in the water harvester. And one of the nice things that we have worked on for many, many years, as I said, the first success was in 1995 in making these materials in crystalline forms, crystals that look like diamonds. But the reason we like those because we can characterize them precisely and accurately on the atomic level. So I'm going to show you how we have been able to observe using X-ray diffraction exactly where the water molecules that are coming from the atmosphere reside inside the structure. And the reason I say that, because to some of you, it may be like it's inconsequential. As long as they are stuffed in there and we're going to get them later, it's no problem. But the key is that if we know where they reside, we can go in and modify that site to modulate how tightly they are bound. And if we can modulate that, then we can modulate the temperature at which they can come out. And that's really the most important development of the water harvester that Eugene has been commenting on. So this is a movie that shows the water molecule. This is the framework. And then you'll see the water molecules, they have red color, and they're going to go into one of these pores that we separate and then slice it so that you can see what's happening inside this pore. So you slice it out. And now the first water molecules go in, okay? And once those go in, they act as seeds to build up more water molecules, almost like growing ice crystals inside the moth at room temperature. And so we know exactly where they are. And as you can see, they stuff the pores. And these pores extend like in a grain of moth, you have billions of these pores, okay? And billions of molecules that end up being drinking water.
Dr. Eugene, did you want to add to that?
Yeah, I'd like to add that what's crazy is that this specific material captures almost 50% of its body weight. So a 1 gram of this moth captures half a gram of the of water, which is unheard of.
Thank you so much for that video. You know, when you think about things at sort of an atomic level, it's kind of hard to imagine. And when you're talking about such like big scales of interchange between like, you know, its own capacity, it's really helpful to sort of visually address some of that, you know, questioning around how this all works. So I think we're ready to turn it over to some of our audience questions. So we actually got some really, really good ones. Dr. Asha, I have one for you. Based on your knowledge, what is the representation of women in your field, and how can we bring more women leaders into marine biology and into that space?
Yeah, so thank you for that question. I don't have any numbers, but on how many women are represented in our field. To be fair, I don't have any numbers off the top of my head, but I think overall there are some fields in science that have less representation than others. I think in marine sciences, there are more women in the early stages, but I think there is, as you can imagine, we lose a lot of women along the way, which is obviously a very unfortunate situation. And how do we up the representation? I think there's a lot of efforts around making sure that, when women get pregnant and have kids, that there are allowances for that, because your career sort of stalls, because we live in this sort of publish or perish life, where if you're not constantly publishing, churning out scientific academic documents, and if there's a hiatus, then you sort of get almost penalized for that, right? And that's kind of the situation we see. But I also think there's a lot to be done around representation, right? So I think the more we see women who are in science doing the kind of work that all of us do, I think that allows people to imagine and dream of what's possible. And I think if we're talking about the futures, right, we're talking about the future of our oceans, I'd like to broaden beyond just thinking about women, representation of women, but I'd like to think about representation of people like myself from the global south. 70% of our coastlines are in the developing world, which a lot of people don't realize. The representation in marine conservation, marine sciences from our parts of the world is very, very low. And there's there's traditionally been quite a colonial mentality around the field, where you have scientists from the more affluent countries, from the global north, or global developed world, as we'd like to call it, coming into our countries, doing research and going, because our countries are kind of riddled with conservation problems. And, there's this assumption that there's no local capacity. People come in and go, and they, their careers are blossoming, but on the ground, it's a very unsustainable model and might cripple the sort of work that's going on the ground already. So I think, the more like people like myself, like I've worked really hard to get into a space where people can see me, because I think it's important. And I recognize it's had such huge knock-on effects. I have an amazing following. I use social media also because I want to make sure people can connect with me. People can really understand sort of what the journey is like. But I think, I've seen an increase in Sri Lanka. I said, when I started out, there were no marine biologists. Today, there's more kids than ever before who want to go into marine sciences, right? So I have then built up opportunities to allow that to happen, from just having our first fully funded PhD and a master's program, world class, to, internships, job opportunities, just engagement opportunities. And a large part of the people who do follow my work are women, because they see me and they think that that's possible. And that's, I think, what we have to do more of. If we want to protect our spaces, we also have to remember, what are the faces we're attaching to the solving of these problems? Who are the superheroes that we're putting out there? And can we show the diversity of people, so that we can ensure that that next generation feels like there is a space for them at the table, and that there are people willing to listen?
You're so right. And you raised so many good points in that comment and that answer. So thank you so much for that generous sharing. I think we know that the future is intersectional. And so when you raise, issues around decolonizing things like climate science, it's exactly how we need to be approaching it. And I remember in my own previous life being an outdoor educator and working on sail vessels and doing a cetaceans, a marine mammals program. Of those programs, the young students who had access to that program really blossomed in, acknowledging their own growth in the sciences. And many of those folks, those kiddos rather, were young girls. So you're so right about not just the representation, but how we share and access what that reach of representation can do to elevate the dialogue and to bring in communities, especially from the global south, where access to this kind of knowledge sharing might be not completely out of reach, but not necessarily the focus of the dialogue as it stands now. Thank you so much for that. Let's see, we have a question for both Dr. Eugene and Dr. Omar. We had talked a little bit about how the water from the water harvester is distilled. What does it taste like is the big question there.
Well, I actually taste this water a couple of times, I should say, from both the The very first unit we built back in 2017, and from the unit you see on the display. And you'd be surprised, but it just tastes like pure water. It's absolutely tasteless or odorless, which means that it's pure.
But to actually make it as drinkable water like what we get in the faucet or in a bottle of water, you just mineralize. You just have to add minerals. It's a very routine, inexpensive process. Then the water will taste nice. Yeah.
Can I ask a sort of follow-up question to that? And totally fair if the answer is no. But have you noticed that different localities produce a different taste in the water that you're actually harvesting?
Well, interesting enough. So as Professor Yagi mentioned before, we've tested a couple of prototypes in the Mojave Desert and the Arizona Desert here in Bay Area, whether it was in lab in the machine shop or even outdoors. And it's still pure water. It's still the same, which is a great thing. It means that it's consistent, it has good quality, and all it takes, just put some minerals in it, and you have probably the best water you can have.
Actually, one of the things to keep in mind is a water chemical formula is H2O. And when it's pure, it doesn't change the chemical formula. So a water on my tongue will taste exactly the same as on yours, and water harvested from Mojave is going to taste the same as the others. But also, I think you're touching on an important point, which is personalized water. Because some people may want their water carbonated, some may want it more mineralized than others, some may want it sweetened. So this harvester could be programmed to personalize your water so that you can have one in your bedroom and one in the kitchen, and they may both have different tasting water. But they all originate from pure water that has no organics and no metals. That's the important, I think, part of this.
I love this idea of a future home where there's multiple water harvesters and we are only gathering what it is that we'll use on sort of a day-to-day basis. It really sort of localizes and shrinks what we are, maybe feel disconnected from with our municipal water systems. It feels quite easy to waste water when it comes from some place where you don't know and you don't know how much is left or you don't know how much you're using. I think, being really closely connected to your consumption could be the next way that we're able to really drive home that point about water awareness, which is also a part of this issue to solve around for water scarcity. But just also fascinating that we could make some more alkaline in the bedroom and more carbonated in the kitchen. I love that future. Dr. Asha, another question for you. There's a comment about obviously oceans are really important, but what if you're a person who's had a bad experience in the ocean or potentially a traumatic swimming experience? What other ways are there to become an ocean advocate without spending a lot of time in or near the water?
Yeah, I think, the representation of marine science and marine biology is very much kind of the work that I do, right? Like out on a boat, like looking for whales or underwater snorkeling. But what people don't realize is it's a massive component of social sciences, right? So if we say you want to be a marine biologist, but you don't want to get into the water, right? So I'm going to break this down into advocacy and obviously science, so that if there's anyone out there saying, hey, I'd really like to work around the oceans, but I have a fear for it, it's completely okay. I mean, we do a lot of social science work where we, like my teams, basically go into fishing communities and just interview the fishermen to try to understand how we can resolve some of those problems, which in turn then obviously have a positive or impact on our oceans, right? And that's kind of our goal, is how do we constantly consider protecting the oceans in the context of the livelihoods and the people around, but also all the other components. So there's all opportunities like that. Then there's also tools, remote tools that you can do. You can deploy a camera out at sea, collect that data, bring it back to your office. One of my teammates, he's written a blog post on our website, oceanswirl.org, called how I studied fish from my bedroom, right? Because we recognize that people can engage in different ways. It's not necessary for you to get wet and, or be out on the ocean and be out of your depth, so to speak, pun intended, I suppose. But I'd say, I want you to know that there are so many ways that you can, advocate for the ocean, engage in science around the ocean, but also advocate for it, right? Whether it's sharing the stories you're learning. I mean, you might have a fear for the ocean that I hope one day you will get through, and I am confident that you will if you have the right support. But I do think that, it's important for us to recognize that you can still be a very strong ambassador for the ocean if you just go out and talk about some of the stories you hear, share what you learn, because the ocean at the end of the day is such an important part of our lives. I mean, we need fresh water to survive, but we wouldn't be alive if not for the oceans, because about 50 to 70% of the oxygen we breathe is generated by plants in the ocean, which is such an important thing for us to remember. So we do have to take care of the ocean. You can take care of the ocean. You can be in your house in the mountains, and remember, we say all roads lead to Rome, but all waterways lead to the ocean. That's a really important thing to remember. So even from your little house in the mountain, maybe in the community around you, you can talk about what you do up there and how that impacts the ocean. So there's loads of ways for you to get involved. And I hope that you will consider continuing to want to become an advocate or engage with the oceans, regardless of the experience you've had, which I hope in the longer term, you'll be able to also work through.
You raised so many great points and how we could find different ways to become advocates in our own right. I think that's a great way to sort of wrap up our conversation. And I think share with our audience and everybody who's joined us here tonight that, these decisions that we make on a hyper individual level, on a day-to-day level, things that we think maybe only have these like minuscule impacts do add up and have real change and capacity to do so. So we invite you to consider your own capacity to become agents of change as we think about not just the future of water, but just the future in general. And I'd like to thank you, Dr. Asha, Dr. Omar, Dr. Eugene, for spending such time with us this evening, sharing so much about your research, your processes, your backgrounds. It really has been a really fascinating conversation, and we're grateful to you for sharing your time. With that, I think I'll turn it over to Donnie, and we'll say good night.
Thank you.
All right, we've made it to the end of our journey. Please prepare yourself back for our landing home. I can honestly say that this conversation has been so motivating. Dr. Eugene and Dr. Omar, please let us know when we can add ourselves to the mailing list for the water harvester at home. Super interested in that. And I'd like some interaction from our online audience. As we close out the evening, there's just a few things. Could you guys just let us know how you feel about today's journey? If you could just drop it in the chat. I can honestly say that I've learned that I too need to be more kind to the water. So if you are online, I love to see how you feel about today's presentation. Jeff Greenspan, I really appreciate all of your questions that you've given our panelists. You've been engaging through the comments this entire time. Okay. Thank you, Austin. You've been amazing as well. We've gotten some really great questions out here. Okay. Well, we hope that you're able to take some of these ideas that you heard today as we work towards moving towards a future that we want, not a future that we fear. Thank you, Dr. Omar, Dr. Eugene, Dr. Asha, Ashley, for joining us on our trip. And to all of our dreamers, makers, and changers of tomorrow who have tuned in, we encourage you to follow us on Instagram, all the social media, Facebook. Make sure you follow Smithsonian AIB and stay connected and check out our website to learn more about our upcoming events happening weekly. Next week, we'll be exploring the future of dating. So make sure you head over and secure your tickets ASAP. Have a good night.
Thank you.